Here we want to prove that the limit of 2x of the function 2x plus 1 is equal to 5 as x approaches 2. And so numerically, as we let x get closer and closer to 2, 1.999, and so here we can see that the x is getting closer and closer to 2. The corresponding y values, they are getting closer and closer to 5. So that's what this statement is saying. 2x plus 1 approaches 5 as x approaches 2. And so we want to prove this statement right here using the definition of limit. And so in this case, let's label some parts of this statement right here. The 2x plus 5, we'll call it 2x, the f of x. And then the 5 here, we'll call it L. And then the 2 here, let's call it C. So L for the limit, and then f of x is the function, and then x approaches C. And so here's what the definition of limit says. To prove that this statement right here is true, or to prove that the limit of f of x is equal to L, L in this case is the 5. As x approaches C, C in this case is 2. Then we must show that for every given epsilon, epsilon is just a small number, like 0.01, or any small number. We must show that for every given epsilon, then we must be able to come up with a delta number such that if x is inside the interval of C minus delta and C plus delta, then the corresponding y value or the f of x must be inside the interval L minus epsilon and L plus epsilon. So that's what the definition of limit says. And it says that to prove that this statement right here is true, we have to show this process. And so once again, the C here is 2, the L here is 5. And so for every given epsilon, we must be able to come up with a delta number such that if we picked an x from the interval of C minus delta and C plus delta, then the corresponding y value is inside the interval L minus epsilon and L plus epsilon. The definition of limit is also written like this. This statement right here is the same as this. So when we say that x is inside the interval of C minus delta and C plus delta, it's the same as saying the absolute value of x minus C is less than delta. And when we say that f of x is inside the interval L minus epsilon and L plus epsilon, then it's equivalent to saying the absolute value of x minus L is less than epsilon. Here's why. X inside the interval C minus delta and C plus delta is the same thing if we write it like this, using inequalities. X is between C minus delta and C plus delta. And now subtract C, then we get negative delta x minus C less than delta. And then in absolute value notation, using absolute value notation, then we have the absolute value of x minus C is less than delta. And similarly, this says that f of x is between L minus epsilon and then L plus epsilon. Subtract L, then we get negative epsilon, and then we get f of x minus L, and then epsilon. And so this says that f of x minus L is between negative epsilon and epsilon. And using absolute value notation, we have f of x minus L less than epsilon. And so sometimes we use this type of notation to prove this statement right here, and then sometimes we use this to prove it. These two definitions, they are equivalent. And so now let's prove this statement right here. So we want to show, using the epsilon delta definition of limit, we want to show that the limit of 2x plus 1 is equal to 5 as x approaches 2. And so to prove this statement right here, we must show that for every given epsilon, there exists a delta such that if we picked an x from this interval right here, or this neighborhood right here, if we picked an x inside of the interval c minus delta and c plus delta, then the corresponding y value, or f of x, must be inside the interval L minus epsilon and L plus epsilon. So let's start with an example. Let's say that epsilon is given as 0.01. Then we must come up with a delta such that if we picked an x from this interval, then the corresponding y value, or f of x, must be inside the interval of 5 minus 0.01 and 5 plus 0.01. And let's say that we picked a delta of 0.001. Then 2 minus delta, 2 plus delta will be 1.999 and 2.001. And notice that this right here, this is equal to 4.99 and 5.01. And now if we picked an x, now we need to pick an x from this interval right here and show that the corresponding y value is inside the interval 4.99 and 5.01. And so let's pick 1.9999, which is inside of this interval, inside of this delta interval. Then the corresponding y value, f of 1.9999, will be 4.9998, which is inside of this interval. But we have to show that this is true for any epsilon. This is just one epsilon. Epsilon with value of 0.01. But to show this statement right here, we must show that for any epsilon, there exists a delta, such that if we pick an x from this delta interval or delta neighborhood, then the corresponding y value is inside the interval L minus epsilon and L plus epsilon. So this is how we do it. We must try to come up with a formula that relates epsilon and delta, so that once epsilon is given, then we can use that formula to formulate delta. And so for this particular example, we have the following. F of x minus L, f of x is 2x plus 1. L is 5. And so 2x plus 1 minus 5 is 2x minus 4. Factor out the 2, we get 2 times the absolute value of x minus 2. And then divide both sides by x minus 2, divide both sides by 2, then we get the absolute value of x minus 2 is less than epsilon over 2. And so this statement, f of x minus L less than epsilon, is equivalent to the absolute value of x minus 2 less than epsilon over 2. So once again, to prove this statement, we must come up with a delta such that if x is in the interval 2 minus delta and 2 plus delta, or another way of saying it is the absolute value of x minus 2 less than delta. So if x meets this condition or this condition, then that implies the corresponding y value or f of x is in the interval of phi minus epsilon and phi plus epsilon. And so what we do is this: we need to come up with a delta that will meet this condition and also this condition. Because if this condition is met, then we will have met this condition. Because this line and this line, they are equivalent. And so we look at this last line here, and then we look at this statement right here. We see that the similarity is the x minus 2. And so what we can do is let delta be epsilon over 2. And so we must show that if we let delta be epsilon over 2, this will lead to the statement f of x minus L. Absolute value of f of x minus L is less than epsilon. So we have chosen this. We have chosen to let delta be epsilon over 2. And this again, this says that x is between this and that. And then now we add 2, we subtract 2. So we subtract 2, and subtract 2. And then now multiply by 2. Then we get multiply everything by 2. Then this is equivalent to saying this: the absolute value of 2x minus 2 is less than epsilon. And this is 2x minus 4 is less than epsilon. This is the same as 2x minus 2x plus 1 minus 5 is less than epsilon. And this is the same as f of x, because f of x is 2x plus 1, and then 5 is L, and this is less than epsilon. So we have just shown that if we let delta be epsilon over 2, then this will lead to f of x minus L less than epsilon. And therefore, we have just proved that the limit of 2x plus 1 is equal to 5 when x approaches 2, using the epsilon delta definition of limit.